All right. So our question is, how are similar polygons related? Because of course, in the end, we want to talk about similar polygons because eventually we're trying to get to similar triangles, and um, similar triangles are going to have relationships just like when we talked about congruent triangles. So that's the end goal. So we're going to use similarity statements, find corresponding lengths, then find perimeters and areas of similar polygons. So the first part of the information, or the first part of the notes, are some vocabulary words that we need to make sure that we're familiar with, which I'm almost 100% sure that we are. So a ratio is a comparison of two quantities, and we're using division. So a ratio can be written three different ways. It can be written as part 1, 2, like the actual TO, part 2, so A to B. It can be written as A colon B, or it can be written as A over B as a fraction. But then you also have extended ratios. And an extended ratio is when you're going to have three or more quantities. So that would be like A to B to C, but that's really representing three different ratios: A to B, B to C, and then A to C. So just an extended ratio is just basically combining multiple ratios into one long ratio. Questions on that? Okay, so let's look at it. So this is an extended ratio, and it says the ratio of the measures of angles in a triangle is 3 to 4 to 5. The ratio of the measures of angles in a triangle is 3 to 4 to 5. So find the measure of the angles. So what are the three angles going to be if their ratio is 3 to 4 to 5? So what do you know about the angles in a triangle in general? What do we know?
It equals to 180.
That the sum of the angles in a triangle have to be 180, right? So that means that, let me get my pen. So that means that whatever my three angles are, when I add them together, then they have to be 180, right? And so the ratio is 3 to 4 to 5. So 3, 4, and 5, right? Okay, but is 3, 4, and 5 gonna get me 180? No. So I need to be able to multiply them by something in order to get 180. So I'm gonna do, I don't know what that something is, and when I don't know what that something is, then I call that something just X. Yep. So now 3x, 4x, and 5x is going to give me 180. So now I need to figure out what that x is going to be. So 3 plus 4 is 7 plus 5 is 12. So I forgot 12x is equal to 180. Divide both by 12. So x is equal to 15, right? So now it's 15. How am I going to use that to help me get to 180? So the first one is 3 times x. So I'm going to have to do 3 times 15. That's going to give me 45. And then 4 times 15, that's going to give me 60. And then 5 times 15, that's going to give me 75. Now, is 45 plus 60 plus 75 180? Absolutely. So that is one way for me to use my ratio to get the values. Questions? So if the ratio of the angles is 3 to 4 to 5, then that's just going to mean that my angles are 45, 60, and 75, right? Okay, next. If there are no questions. Proportions. So an equation stating that two ratios are equal is called a proportion. So a proportion is an equation with two ratios. Proportion is an equation with two ratios. So in a proportion, A over B equals C over D. And so A and D are your extremes and B and C are your means. And you don't necessarily have to remember that A and B, like that they're called your means and they're called extremes, but you do need to remember their locations because A is always the diagonal from D, C is always the diagonal from B, so that when you find the cross product, they are equal. So AD is equal to BC. So first, let's look on the right at the equivalent proportions. So I said, and I don't know why that's on there twice. Okay, so A and D, notice that they are at the diagonal and that C and B are at the diagonal, and it doesn't matter if it's top to bottom or bottom to top or where they're located, but that always needs to be their relationship. Okay, that always needs to be their relationship. And so that relationship creates the cross product so that you have AD is equal to BC. And so that is the butterfly method that we always want to do. And we get confused, but butterfly or the cross product really is always over an equal sign. So it has to be an equal sign in the middle for you to be able to do a cross product. Can't be anything else in the middle except for an equal sign. Okay. Okay, so I want you to take about 2 minutes to look at these two problems, and then we'll do them together. So this is using cross products. So how would you use cross products to find the value of y in the one on the left and to find the value of x in the one on the right? 2 minutes, then we'll do them together. Okay, let's look. Hold on, I got a message. Hold on. Okay. Now, what we need to do is use the product. So we are going to look here, right? And then here for our cross product, right? So that means we're gonna have 6y is equal to 18.2 times 9, right? Okay, so then 6y would be equal to, I got a sticky over here, 163.8. And then we'll divide both sides by 6. So that y is equal to 27.3. Okay, so this is going to be 27.3. And then therefore now we have two equivalent fractions, a proportion. Same thing on the other side. We're going to multiply here and here. So 4x minus 5 times 6 is equal to negative 26 times 3. On this left side, we have to distribute. So that's going to be 24x minus 30 is equal to negative 78. We're going to add 30 to both sides. So 24x is equal to negative 48. Divide both by 24, so x is negative 2. So if I were to put x up here, that's going to give me negative 8 minus 5, which is negative 13. So negative 13 over 3 is equal to negative 26 over 6. Questions? No? Okay, so let's keep going. And I just want to go a couple of more slides before. Oh no, we're going to stop right here. We're going to stop right here. And what I want you to do now is I want you to go into your Google Classroom. Okay, so I just put a Google form in Google Classroom. And in that Google form, basically what you are doing is you are looking at proportions and setting them up, making sure you know how to set them up vertically, horizontally, and making sure you know how to find the cross product. So it's only about ratios and proportions. It's not asking you anything about similar polygons just yet. So I'm going to set the timer for 30 minutes and give you 30 minutes to work on it. And then at the end of the 30 minutes, we're going to come back and then continue here at this similar polygon slide, okay? All right, so now we're talking about similar polygons. Hold on. All right, so two polygons are similar if they have corresponding angles that are congruent, but the corresponding sides are going to be proportional. So that means what you're going to end up having is you're going to be having end up with two shapes that are two different sizes. So the angles will be the same, but the sizes will be different. So this particular slide shows you different things that you will have in similar polygons. If you look down here at the bottom, if I can find the mouse. Down here at the bottom, can y'all see the mouse? So do y'all see this little line right here? It is the squiggle that is next to the 1 on the keyboard. That is the symbol to show that two polygons are similar. So ABCD is similar to WXYZ. And if we think about it, the congruent sign is that symbol with the equal sign underneath. So it's similar to that congruent symbol, okay? So our angles, our corresponding angles are congruent, which means that A is congruent to W, B is congruent to X, C is congruent to Y, D is congruent to Z, but then our sides are proportional. So AB is proportional to WX, and if we look, 15/5. And then we see that DC is proportional to ZY. That's going to be 21/7. Well, 15/5 is 3, 21/7 is 3, right? So when we look at that, we should have the same value for whatever our proportion is, okay? So let's talk about making predictions. And this is really about making predictions, but it's also about being able to set up our proportions to ensure that we are setting them up accurately. So it says, Brittany randomly surveyed 50 students and found that 20 had a part-time job. If there are 810 students in Brittany's school, then predict the number of students with a part-time job. So we need to look at this so that we can make sure we understand the two different ways that there are to set up proportions, okay? Before we get into our similarities. Okay, so it says that Brittany surveyed 50 students. So that means we have a total number of students. And then we also have students with part-time jobs, right? Okay, so when you are setting up your proportion, you can either set it up horizontally or you can set it up vertically. So the first one, let's set it up horizontally. So when I say horizontally, that means we're going to do total over part-time jobs. All right, so it says that she surveyed 50 students. So that's going to be the total number of students. And there were 20 with part-time jobs, right? And so that is going to be equal to, she said that there are 810 total students in the school. And we need to know how many have part-time jobs. So we're going to say X because we don't know. Okay. So this problem or this proportion is set up horizontally in that the totals are across the top, the number of part-time jobs on the bottom. We could also set it up vertically where she looked at 50 people. That's really ugly. So she asked 50 people and 20 had part-time jobs, right? There are 810 people in her school and she wants to know how many have a part-time job. So now it is set up vertically. Are these the same? Absolutely. Because when you find the cross product, what happens? 50 times X is equal to 20 times 810. Right? Do I get the same thing over here? Absolutely. Right? So you just want to make sure that whatever they share in common, either that lines up horizontally or that lines up vertically. So if I have 50 here, I cannot have 20 over here. Those don't line up together. They don't line up horizontally, nor do they line up vertically. So then if I go through and solve this, I have 50x is equal to 8 times 2 is 16, 200, all right? And then X would be equal to, we'll take those off. 16 goes into 5 3 times. And 5 goes into 16 3 times. 5 goes into 12 2 times. 5 goes into, is that right?
Yeah.
Yeah. All right. Am I missing a 0?
No.
Okay. All right. So then approximately 324 students in the school have part-time jobs. Okay. Questions? Okay, so what is important for us here at this point is that we make sure that our information either lines up horizontally or lines up vertically, because then when we start moving into shapes, then we need the same thing. Okay, so that's going to happen when we get to our polygons, but we'll do that next time because it's time to go. So we'll start at slide number 10 when I see you all on Thursday. So for the people who are online, then you are free to go. And for the people in the class,